is what are the constraints there is it cannot move along the horizontal direction as well as the y direction, but it is free to rotate due to any changes of length, no? So this is an example of a pin support. This is a pin support of, I think this is a bridge. No, this is a bridge. So that support is attached to the structure called abutment, no, or maybe pier. Okay. So this is a pin support. Now, this is also another example of a pin support, no? It's connected to a member, but this one is bigger. Yeah. These are big structure. These are bridge, no? Big structures, really. No? So if you want to see the figure, the car and the size of the support, see that this structure is really big. Of course, this is the support of the bridge. Okay, on one side. This one also is a big structure. So if you see, the height of the man and the size of the member is, you can see, you can judge, no, from their sizes, how big the member is. And so that is because you can find a pin, meaning that member is free to rotate about the pin, but it cannot move along the horizontal as well as vertical. That is a pin. So this one is an example of a pin support. Okay. Now, if you are going to idealize it, okay, you want to idealize it. So this is the idealization of a pin support. Okay. So sa mga books, mugawas mo na ni siya, no? Meaning na there is a reaction along X. So if I'm going to put a reaction here, na siya reaction diha. Yung reaction. So tawag na to na siya o reaction. Kita ninyo niya akong gisulat? Nga araw? Sa pag ginaani, RY, right? Na siya RY. Okay. So muna ang iyang reaction. Now, this member is continuous. It's free to rotate about this pin, no? So meaning that if there is movement down, so what happens is that this structure will just rotate about. Okay, so mag-rotate lang siya, no? But this structure is intact, meaning it's supported along the y direction, along the rx direction. Okay, this is the action of the pin in 2D, no? In 2D. Of course, it can support also RZ, but RZ is perpendicular to the surface here, no? Sometimes when we analyze using maybe long hand calculation, we convert a 3D structure into 2D structure, but very seldom in reality that you can find a 2D structure, no? Unless kana mga mga door lang, no? Door nga window, mga arcs. So muna siya mga 2D structure, but it's very rare. In reality, all structure is 3D. Okay, structure is 3D. Okay. Another way instead of this is kini simplified, no? This is simplified niya, idealization. So nagyapon ni siya Rx there. Okay, so those are the reaction. Okay, and this beam is free to rotate. Okay, so that is pin support. Okay, so any question?
None, sir.
Okay. Ang equivalent ani niya is kung 3D siya is a joystick, no? A joystick. Remember, balo ka sa ang joystick, no? Ang joystick is free to rotate in any direction but cannot move along X direction, Y direction, and Z direction. Okay? So, this one also has RZ, but you cannot see RZ because it's perpendicular to the paper. Okay? So, also this one. Okay. So, now you have see in actual what is a pin support. Now, let us go to ruler because sometimes simple beam, no? Ano nga I'm talking about simple beam. Tungod kay sa hindi ka manguha dia. Hindi mo kuha nimo. Ano lang ito ng oh, kagana kanan. Okay, kadalan nimo kuha dia. Panggaan. Oh, ano ako? Oh, gabutin niya. Okay, plastic. Okay. Okay. Okay, so I'm talking about simple beam because initially we will start analyzing simple structure because simple structure is doable, no? We can solve it right away using principle of equilibrium. And whatever knowledge we gain from it, we will use it to solve indeterminate structure. That's why we always start with simple one before going to complicated one. And mostly, simple structure are the supports are pin and roller. Okay, support I've shown you the pin. So how does roller support look like in actual? Okay, this is how it is. This is a roller, no roller. It can support vertical but not horizontal. So this one can roll, no? If there is an expansion of the length of this beam, so this one will roll. But the movement is just very small, okay? Very small. Okay. But this one cannot support horizontal reaction. But yeah, this is it. This is one of the reaction of the support of the maybe bridge girder. Wherein in design it is a roller, so in actual a roller really is implemented, no? So that is example of a roller that it's free to move on the X direction but constrained to move along the Y direction. It is also free to rotate. Okay. Another example of a roller is this one, no? You have a roller. So it is free, it has some freedom to move horizontally, but restrained to move vertically. Okay. So this roller is maybe to facilitate easy movement along the X direction without without frictional resistance. Okay. Because if you just put it directly on the cement without these rollers, well, it is free to slide, but sliding is difficult because of the friction. And you know, the frictional resistance is dependent on the coefficient of friction between the material and the normal force of the beam. So the normal force here is the reaction. So if the reaction is big, so sometimes it is difficult for this point to move horizontally. So as a solution, the designer put a roller, okay, so that it is free to move. Okay. Now another example is this one. No? This is a roller, a continuous beam. So this is a roller put on a pier. So the structure so below the pin, what we call a roller. Of course, doon na siya plate, no? Okay, kung ang roller in contact with the concrete, and the concrete has smaller strength, so there might be some bearing problem here, no? Bearing stress problem here. So that's why doon nalagay siya mga plate nga gibutang para yang daganan. Okay. So how does it look like in the book? Sa atong pag-solve din, it's look like this. This is a roller. So meaning that this can support only vertical. Okay, not horizontal. So this one. So why hindi man siya makasupport horizontal? Because kung doon na siya force, dagan naman siya. No? But most force are vertical. No? Most force are vertical. Gravity only, like the weight of the bridge. Okay. So this one also, no? So you have a simply supported beam. So how does a simply supported beam look like? So we have here an example of a post and lintel, no? So meaning that the vertical are called post, while the horizontal member here are what we call the lintel. That's why sometimes we call it lintel beams, no? Lintel beams. We can also call it beams, no? Beams. Okay. So these are posts and beams. Okay. The posts are just put directly on top of the post or the flat surface of the post. That's why it is considered as a simply supported, no? Simply supported. Although kung ako'y pabuto na unstable pag ini siya. Why? Because if there is a very large horizontal force such as strong earthquake, this one will simply, the beam here will simply fall down. Why? Because the inertial force of this rocks is strong enough to tackle the lintel of the column. Okay, so it's like that. Okay, so continue. Let's continue. Awesome technique one. Okay. So mo na siya, no? Yeah, kini sang isa ka figure on the right. Mo gyapon ni siya lintel beam mga post, ano man, na may post, no? Post. Okay nga, kini mga vertical member, horizontal member are what we call beams. No? But these are girders really. This is a bridge. Actually, this is a bridge. And you can see the equipment at the top. This is a modern girder launcher. No? So it could launch girder in just few hours. No? So makabutang sa girder in just few hours. No? Asahon niya ng girder, then kini siya move to the other point, then inya na sa ibutang. No? So yung ang trabaho niya, tigbutang ng girder. Kining girders, gipabricate na ni siya daan dito sa layo, no? Factory, sometimes this factory manufactured. Why it is factory manufactured? Because in the factory there's stringent quality control compared to done in the site. And also in the factory, it requires less scaffoldings here. If you put scaffoldings here, so money will be wasted. Okay, and it's not very fast. Okay. So that's why they have recasted all the elements and then post it here, no? Then use a girder launcher. Okay, so you have here an idealization of pin and roller support. It's like this. So this is a pin and this is a roller. Okay, and one question: why we need to idealize structure? Because we cannot analyze a real structure. We need to model the structure into idealized structure. Okay, and this one is already idealized. No? So the horizontal line here represents the beam, and the arrow represents apparent load, and then you have also uniformly distributed load. And the triangle here represents spin, just like this. Okay, just like this, spin. And the circle here, or the roller here, or nalimtan ni butang ako ng correction na butang na ko siya. Ano yan na? Yan na din. Jadi kabalo ang mo din. So mo na siya roller. No? So roller should look like this or would be this. No? Nagi siya nga na, nagi siya support. Eh kung circle lang, di ko ganag tanaw adto. That means na butaw lang gyapon siya. So butang gyud siya ikuan. Okay. Now, kung ma-present na gali nimo ang type of reaction, type of support sa imong structure, kanya mabutang nimo ang tanang loading, pwede na nimo siya ma-analyze. Makuha na nimo ang iyang primero imong kaon is reaction pa, no? Reaction. Okay? Makuha nimo ang reaction. Okay? How? Kung simple lang yang structure, gamit lang ka og equilibrium equation. Okay? Unsa man ang mga equilibrium equation? Okay? Okay. So, okay sa takayot unsa na? Una-una sa nato unsa na equilibrium equation. Anybody sa inyo kabalo og kuan unsa na equilibrium equation? Tawgon ta mo ha, Mr. Medrano. Miss Medrano?
Sir?
Unsa imong nabawaan about equilibrium equation?
In equilibrium siya, sir, if equal to 0
Ang iyang
ang mga reactions.
okay, ang mga reaction equal to 0? No, not that. So, kung ako i-correct na siya, siguro ang summation of all forces is equal to 0. Equilibrium siya, no? Dili reaction. So, panalitan na ay object, no? So, nag-rest siya sa table. Okay, let us say a glass, no? A glass. So, the glass has weight. Now, without the table, ang glass mahulog siya. Tama nga doon ay makasawa sa iya. But, that's not happen. Why? Because the glass is held by the table. Okay? Na table nga nagsalot, nag-alsa sa iya. And if you try to model that one, doon na siya gitawag nga support. Okay? So, ang table, ilisan mo siya o maybe triangle, no? Or a ruler for some sense. But there is no horizontal force. That's why it is still stable. Okay? It is still stable vertically. But not horizontally, because horizontally, if you try to push the glass will just slide along the surface of the table. But if you just push very little, you cannot push the glass. Why? Because there is frictional resistance. But, you know, frictional resistance is just very small. No? It depends on two factors, the weight of the glass and the coefficient of friction between the glass and the table. Okay? If, for example, the glass has no content, it's empty, so it's lighter. So, just little push, you can push it. But if the glass is heavy, it contains a heavy liquid. So, it has a very, it exerts large force towards the table. Okay? So if you push it, you need to increase the force to push the glass, just to break the frictional resistance. Okay? So if you are going to sum the sum of the weight and the reaction, that should be 0. No? It should be 0. Okay. So that's it. Okay, let's go back. Let's go back. Where is it? Can find it here. Okay. So once you have already the reaction here, let us see that is the reaction. Okay. You say you solved that already, and there is a reaction here. Okay. But this reaction here is 0. Why? Well, my force, no horizontal. The point load is directly downward. The uniformly distributed load is again downward, no? Downward nga presentation. So meaning, wala siya ay force na horizontal. So even though makasupport siya og horizontal, pero RA is 0. R E E is 0. Okay? So at point A, where the beam is supported, there's only one reaction, and that is REY. Call this R E Y. Okay. Now, if we go to B, B is a roller, and as we have analyzed earlier, roller cannot support the reaction in direction of the roller. So there is no such thing as RBX. So, but RBY, yes, there is R. B Y. Okay? So, even though tulo ka book ang reaction niya, but to simplify, walaon na nato ning RX, ato na ni siyang walaon sa picture. Kaya ano man, para ma-simplify pag further, himo na lang duha mo anon instead of 3. Kaya nabuka naman mo siya nga 0. Okay? So, pwede na rin kang apply of equation of equilibrium, such as summation of B equal to 0, summation of moment about B is equal to 0, or summation of moment about A equals to 0. Now, you need only two equations kay duha man kanon so two equation is enough, no? But if you are going to use summation of forces Y, kulang pa na siya. Ano man, duha may anon. So, pag yung summation forces Y, ang equation is REY plus RBY, those are the forces going up, minus forces that goes down. So, minus the point load, and minus the uniformly distributed load multiplied by length AB. No, that is the length where the uniformly distributed load is acting. No? If the uniformly distributed load is only acting partial length of the whole beam, then you use the partial length of the whole beam only. Only the length where the uniformly distributed load is acting is multiplied to the uniformly distributed load. Why we need to multiply? Because the unit of uniformly distributed load is not the same as the point load. The point load has a unit of kilonewton if we are using kilonewton, and then the uniformly distributed load in this case will become kilonewton per meter. You know, you cannot add kilonewton and kilonewton meter. You need to convert the kilonewton per meter into kilonewton so that you can add it to the kilonewton. That's why it needs to be multiplied with the length at which the uniformly distributed load is acting. Okay. So, and then, kulang pa kang isa ka equation. So, either you sum up moment about A equal to 0 or sum up moment about B equal to 0. The reason is, we need to determine the reaction first before determining the internal reaction. So, external reaction first, external forces first. You need to apply equilibrium the external reaction so that all external forces are determined. Okay. Walay kaso ang given, kay given mo na sila. Pero katong mga anon, just like the reaction, is wala pa man na siya before mo siya isolve, pero they are there. Only that you need to know what is the magnitude of it. Not you cannot determine it unless you solve it using equilibrium equation. Okay. So now, kini nga diagram, tawag na dato na siya og load diagram. Ang load diagram is a diagram of the structure or the substructure wherein all external forces acting are there, no? So including reaction because reaction are considered external forces. Okay. Dapat may buuan na siya. Okay. So that you can determine the internal forces such as the shear force within at any point within the beam and the bending moment also within any point within the beam. Okay. But shear moment has to be done one after the other. No? Okay. So, di man ta computer, kita ta. So, di na to sila madungan. Yung tao, computer atong utok, kay pwede na to na. Pero, we are not computer mind. No, yeah, it. And we don't have the capability of one computer mind, and we do not want that. Okay. So, we determine the internal forces one after the other. So, shear diagram first. Okay, shear diagram. Okay. The shear diagram actually is the representation of external forces, no, at any point within the beam. Okay, at any point within the beam. Okay, so it is a graph, no, it's a 2D graph wherein the y-axis represents the shear force and the x-axis represents the length. Excuse me. Hello. Good morning. Ay, Ramon, okay. Sige, I'll get it. Good morning. Happy New Year, Sad. Sa Baloy. Dagan na rin. Ay, no, 11,000. 11,000. Divided by, pinagay na ka kilo, 11,000 divided by 3, that's almost around 500 solar. Oh, so, mga 400. Kung sa man na nga structure, ang kuhan, hardware, hot cherry. Aka, kan kuhan, kan alwana. Adi, kasalo. Istong. Okay. Iwat ka rin. Ikaw ito na, ano sa, lagi sa tukod, ano. Tagay lang mi og time siguro, architect. So that me and my engineer can investigate it. Now na itong old structure, we will see if the material used in the structure is really nag-degrade na ba din siya or it still use the strength nga nasa iya or how much among i-reduce sa iyan ko ang among assumption. And second, we can analyze if it can still carry extra load. Yan na. So, tagay lang mi og mga siguro 2 weeks is okay. Mag-quote siguro may ikaw sa nga week. Magtanaw sa mi una. Kung sa kadako. Pila ka square meter ka ang structure niya. Katuban ng kuan, katuban ng commercial motor sa una, business. Sa likod, sa bangko lugar. Sige. Pero I need to see it personally. I think, we need actually to determine the type of support para ma-complete na to atong load diagram. Okay. Ining diagram nga dunay load, okay, point load, uniformly distributed load niya, napo diha ang beam, yan ay type of support niya. Ang type of support, pwede rin mo siya pulihan of force. Ano yung kitawag og load diagram? Okay. Yeah, ang next yung mga bahato is the shear diagram. Okay, ang shear diagram, graph na siya sa kuan. Yes? Okay. Uy, nakutas na. Ayun, dili na. Wala, ay, ang technique na to, 0.6, ako na siya. Kana lang dili mula pa sa 0.6. Okay na. So, bayan gina rin yung structure. Kuan. Either, hindi ang yapon i-plate ko na atong treatment. Kung ano po siya mga ribs ba? Mga frame. Ayan, natubukan ng plate ko, mabawag na siya. Pila sa gipis ng plate kung gusto niyo mo. Na 4 mm. Basta doon na siya backing, kasi mga backing ng mga bulbara na. Okay. So, this is now the shear diagram. Kung na unsa man ang shear diagram is just a 2D plot wherein the horizontal axis is the distance of the beam, and the vertical is the forces, that's acting on the beam. Okay. So, right on this picture, okay, at this point where the reaction acts, we know that the reaction is going upward. Okay, so that's why we have a red arrow here up to there. So that is this distance from here, from zero. I label this as zero. Okay, zero meaning this is the origin of the graph, and going here is the length of basically the x. The unit is meter, and going up is what we call the v. No, is going there. That's the v. Okay, v. V represents shear. No, shear. Okay. Most symbol for shear is v. No, I think dunay reason na ng v siya. No, v. Okay, v is shear. Okay. So right at this point, at the beginning, where point A is acting, you have an arrow. This arrow represents the magnitude of the reaction. Okay, na magiging reaction sa A. Okay, and then you notice that from A to the midpoint, there is none. No, before you reach the point load, there is none. There's no other. There is a load, but you have a uniform distributed load, meaning hinahinay, no, hinahinay nga one. Distribute nga load, no? So na function na distribute. Okay, now that distributed load, especially if the loads here are going down, can be represented as a line sloping down, no, as you progress towards x, positive x, the line is reduce, the line is sloping down. That means that the sloping down represents the small force at every distance, at every uniform interval along x here, and that is the effect of the uniformly distributed load. It will continue, no, until B. But why there is a sudden break here? Why there is a sudden break here? It does not continue like this. Wait, why it does not continue like that?
Tungkol sa point load, sir.
That's correct, no? Correct. So there is point load. So let us say the point load here is not given, but let's say this is amount like that. Then after you consider the point load, from that point up to B, it's the uniform distributed load again acting. So you continue to slope down like that. Stop here. Okay. Anybody anong go up na sab siya from this point?
May reaction pa sa ka, sir.
Yeah, at point B, ganun ni go up na siya na may arrow up.
Reaction, sir.
Okay, that's correct. Reaction at B. Okay. So this is what we call the shear diagram, no? So we have the positive shear here, meaning from between E to the midspan, you have a positive shear because look, all the shear here is above the horizontal line. But somewhere at the midspan towards the right support, the shear is below the horizontal line, meaning this is negative. So this is a positive shear. I label it that one. And negative shear. Okay. But okay. Now, property of the shear diagram. Property of the shear diagram. The sum of the, if you are going to consider an area here, no? If you can compute the positive area and negative area, the positive and negative area, the sum of them is equal to 0. Okay, the sum of the positive and negative area is equal to 0, meaning that if the external forces are equilibrium, the internal forces also is in equilibrium. Okay, the internal forces is in equilibrium here. Okay, so that is one property of the shear diagram. That the sum of all area, okay, algebraic, because you consider units. If you have positive area, you will leave it positive, and you have a negative area, that is a negative. So if you add positive and negative, it will neutralize, no? Itself. It will become zero. And the equilibrium is demonstrated. Okay? Now, actually, ilang gitbutang next from the shear diagram is the moment diagram. Kining moment diagram is also a 2D graph, but the vertical axis of this one is the moment. Moment is variation of moment along x. So this is the moment. Okay, moment. Ito siya function of x para di ba naman siya vary man siya distance x, no? Moment. Okay. So while this one is going there, is also x in meters. Okay. Now you have two area, positive and negative, and this area is not a rectangle. Unsa man yung area tawag niya ni? Unsa man nga shape ini?
Trapezoid, sir.
Trapezoid.
Trapezoid. Ang kini siya,
Parehara gyapon, sir.
kaya gyapon trapezoid. Ang naka-differential lang sa ila is negative ng isa, ang isa positive. Right? Okay. Pero kini yang diagram is kung ano kayo ni siya, oversimplified na kayo ni siya. Ano man, continuous mo gud ang kurbo, I do not believe na continuous na siya. Yung ano man, na may disturbance, na-disturb man ani nga kuan. So, if I am going to redo it, it will like this. It's still a second degree. Okay? But still, instead nga sweep siya kayo nga paingon dito, doon na siya gamay nga kuan. Swing ana na siya. So, dili siya nga continuous ba? Doon na siya ganin, doon na siya gamay nga ham, no? Nga, dili siya continuous. Why? Because of the disturbance of this one. Okay? So, we can now kuan that from the shear diagram, nag-ingon siya nga, the point of zero shear is the maximum moment. Okay? Diba naana siya sa inyong kuan? So, aside nga ang sum sa area sa shear diagram is equal to 0, doon na pag ginaingon nga, the point of maximum, the point of zero shear is na diha ang maximum or say minimum moment, no? Minimum moment. Diya di mo makita ang maximum or minimum moment, whatever. So, makita na nimo, no? Kung maximum ba siya or minimum. Okay. So, let us first consider this area. Yung positive area lang. Ang positive area nag-cover sa first half of the length of the beam. Okay? For example, if this is L, this one is L divided by 2. Okay? L divided by 2. And looking at the shape of the shear diagram, it is trapezoid. So, instead na constant ay ang slope up, we know nga digit siya constant going up. Mag-anam siya o mo curve down siya because of the effect of this one. No? The effect of this one. Okay? Kung nga na lang tato yung shear diagram, rectangular, okay, you can make it straight like that. Okay, meaning nga, mo gyapon yung rate bisag unsa ang kuan, bisag unsa ka kuan ang yang x, ang iyang rate mo gyapon, pareha gyapon ba nga tanta na kay constant na money mo abot mo everyday. Ito si doon na kay 10 pesos per day. Nya doon na kay let's say ang length ani niya is 10 days. So every day doon na kay 10 pesos, so that kay 10, second day you have 20, you have 30, 40, 50, 60, 70, 80, 90, 100. So at the end of the 10 day you have already 100. So yun na. But this case, you have a trapezoidal which is going down in this case, but these are all positive, meaning positive area gid siya. So your slope now, sa batong one, ano niya? Go back. I do not know how to go back. Ito ba lang command niya? Lain na ang color. Color na. Okay. Okay, so ang kita mo ka niya is mana na siya to. So anam siya gagamay. So slope down na. Ana siya. Then whatever the area of this from this to here will be the moment maximum. That's the highest it can reach. No, that's why it's called the maximum moment in max. Max. Okay, max. Nganong maximum man nganong napa may laing area nga mudugang sa iya. Dili man ni dugang, minus man ang uni. Minus man siya. Nganong minus 1? Negative area good. So negative good siya. So negative yung area. So instead nga madugang siya, minus na yun siya din. So as you go to from midspan to the other end, always minus na siya, no? Pa-minus. Yung minus niya, ga-increase. Ga-increase, no? Gana mo kadako yung minus, gana mo kadako yung minus. May tabuan na niya, is muna ana siya. Like that. Now, it go back to 0. Why? Positive area and negative area are the same. So, sure, it go back to 0. So, 0 yan ko na siya. So where's the maximum and minimum? At the midspan and at the ends. No? Support. So you can see here's the maximum. But in this case, hindi ta ka-determine o magnitude. Kaya nga naman, wala mo sa magnitude sa load. No? Magnitude sa load. Butangan na to. Butangan na to din siya. 100. 100 PL. Okay, 100K. As an example. Nato siguro ni Edson. Okay, so itong Edson ha. Sino dito is? Okay. Ano siya? Let us say ang il niya, pila kaya itong il? 8 meter lang, 8 meter, para dali lang. Satu papi nih, 4 meters nih. Oke, siapa meters siapa? Pila kaya ito yung butang sa uniformly distributed load? Pila ka? Ano sa may masayon? 5, 10, 20? Lang. 20. Ang unit niya is kilonewton per meter. Okay? Ready na mo, class? So, the structure is very symmetrical with respect to vertical axis because the point load is located in the midspan of the beam. Okay? And also, the 20 kilonewton per meter load, which is acting downward, and it is distributed throughout the length EB, which is 8 meters in length. Yeah, is there. No, it's covering the whole span, 8 meters. So in other words, the total load generated by uniformly distributed load is 20 times 8, that is 160. You have 160 kilonewton load sa uniformly distributed load lang na, ha? Duha magkaklase nga load, duha may 100. So, pila man tanan ka load ang naa, pila may magnitude sa vertical load na subject sa beam. Pila? Anybody? Okay, kasi maka-answer kung pilay load ang total vertical load.
260.
Ha?
260.
Okay, so that's Mr. Tabilla, I mean. The total load is 160 plus 100. They are all going downward. Okay. Para mag-equilibrium, pila man ang reaction. Tayo na sab, pila may reaction niya. Kasi mag-answer are you Miss Duty or Yuti? How do I pronounce your family name? Miss Kayla Maris? Kayla Maris?
Yes, sir.
Yeah. Are you? Okay. So, so that there is, according to your classmate, that the total load going down is 260, and that 260 is the sum of the uniformly distributed load acting the whole length plus the concentrated load. They are all going downward. What is the reaction to that? What is the reaction? You know?
260, sir.
Oh yeah, 260. And what is the direction of 260?
Upward, sir.
Upward. So You know, class, it's upward. The 260 going down must be met by 260 upward so that the sum of the all the actual all the external forces, because external forces man ang reaction, external forces yapon tong load nga nag-act is zero. And there you have equilibrium. Okay, there you have equilibrium. So 260 is the reaction going up. Now, if the 260 is the reaction going up, what is the value of RA and what is the value of R sub B? Okay, kasi makatubag.
130, sir.
130 and 130, correct. Okay, so let us go there and determine. So this one is going up there. This should be an arrow there. Okay, we don't need to, we just consider the property of kuan lang, kanang gitawag nato nga symmetrical, no? So we do not need to sum up moment in that shot. We can determine 130 kilonewton because klaro naman kayo nga balance ang loading. So balance ang reaction. Okay? So kung imo gyud na siyang gubitan og subdivision of moment about D, mao ra gyapon makuha nimo. So this is 130. Okay. And you know, unit is very important. You have to take time to write the units, no? Okay. If you have only 130, we do not know what is 130. But if you put kilonewton or pounds, we already know that that is a weight. Okay, somebody is there. This is Paday. Why are you late, Mr. Paday? Why are you late? Manit ba? Okay. So, meaning na ang load diagram nato is complete na, no? Equilibrium na siya. Okay? But dili pa ni mao ang analysis. Kaya atong analyze sunod is ang shear. Ang shear og moment kunang gitawag og internal forces, no? Internal forces. Ang mga yung nasa load diagram mo gitawag og external forces. So ang internal forces such as the shear and the moment makuha lang nila mo once na na-equilibrium ang imong load diagram. Okay. So, makuha na to ni siya one by one, no? One after the other. Una-una to ang shear diagram. I had a moment. Okay? So, anis ito sa shear. Okay? Okay. Ato na lang yung gamiton yung diagram, no? Although sa una, wala pa ni siya, no? So, along point A, doon na tayo vertical going up. Okay? So, ato nang i-reason ng uban. I-reason tayo na sige na. Okay. Okay. Isunod na siya. Isunod na siya. Okay. So, hindi sana na ako og color. Color. Yeah, kada. Okay. So, sa support pa lang gali, doon na kay 130. 130. Instead of butangan nimo og positive, di na lang kamutag positive di tapos sulat nga ano. 130 na. Nang 130, nawalay sign, that means positive na siya. Nga, tawag to. Okay. Now, between A to the midspan, walay laing load kundi ang uniformly distributed load lang na 20 kilonewton per meter. So from A to the midspan, the load that is acting on your beam in the beam or on the beam is 20 kilonewton per meter. Uniformly distributed load. So per meter, it already gone down 20. Another meter, another 20. another meter, another 20, another meter, 20. So after 4 meters, so 20 times 4, so the first half, for the first half, 20 times 4, that is 80. So you have 130 minus 80. Why minus? Because this load is going down per meter. And how much per meter it goes down? 20 kilonewton per meter. So for the total 4 meters, it has gone down 80 kilonewton already. Okay, the unit becomes kilonewton na. Kaya ito naman multiply sa 4 meters. Okay, 130. So then the first here you have 110. That's 110. As a equation. So dapat dinirepit no, dinirepit. Ini siya. Yeah. Ini siya 110 ini siya. Okay, 110 ng kakarameter. 20 ng kakarameter ang minus. It has given a sign of minus because this uniformly distributed load is going down. Unya sa sulod nga meter na sa 20 lang gyapon, so 90 na. Nya mobusab ka becomes 70. And then you have 50. Kilonewton. Okay, 50 kilonewton. So here you have a positive area. Positive area. Okay. Now, at this point, there is one load, no? Na dapat diliin mo kalimtan. Kaya naagi na siya. And that point load or concentrated load is 100 kilonewton. Okay. Okay. Gabi kay kahait, no? But in actual, dili na siya hait, ha? Doon na siya gitawag base plate or footing, no? Na siya itawag footing. Okay. Kalagsa ka maka-encounter yung hait kayo, no, sa actual na load. There's no such thing as that. So, even a person standing can be considered as a point loading, but ang feel sa tao, dili man hait, no? Doon naman siya lapalapa, doon naman siya area. Okay. So, in such a way that your load and the area, you are causing stress because force per unit area is stress or pressure, no? Pressure. Force per unit area is pressure. So if you have force only, that's kilonewton, acting at a point. So when you say concentrated load, that is already a resultant load. Okay, resultant load. So you have a positive area here, so you have 100, so you have 50. That is only 50, so it goes further pa negatively, so this will become negative 50 kilonewton. Okay. So naka-negative 50. And going to from the midspan to the other end is it takes 4 meters. So every meter there is negative 20, negative 20, negative 20. So the first meter it will become negative 70. That is okay. That is the height from this point up to that. And the here and there, negative 70 minus 20, that's negative 90. And then here you have negative 110. And the last, you have negative 130 kilonewton. And then exactly here, doon naman sa kay vertical arrow, which represents the reaction amounting to 130 kilonewton, and that is directed upward, it go back to 0. That means if this is the negative area, it go back to 0, like that. Now you expect sa shear diagram na at 0 shear, na diha ang mga critical value sa moment. Ang critical value sa moment is either minimum and maximum. No? Minimum and maximum. Muna sa critical value sa moment. Now, there are 3 points at which the shear is 0. One is at the start, and one is at the end, and one is at the middle. So, those points are very important to watch because critical moments are there. The minimum and the maximum moment are there. So, any question about the shear diagram, class? Any question about the shear diagram? Miss Darapa, where have you been? Okay, class, naamoy question about the shear diagram? Basig na sayop ka?
Wala,
Okay.
sir.
Wala, okay na. Padayon. So, let us continue. Let us draw the moment diagram. So, the moment diagram looks like this. Okay, it should be curve, curve, curve down, curve down, curve down, curve down, but not continuous. Okay, there. So, let us analyze the first half. Okay. So, let us consider this area 1, and area 2. If I'm going to ask you, which one is bigger, area 1 or area 2?
1, sir.
Okay, so if I'm going to divide this, so this one represents area 1, which is bigger. Okay, that's area 1, that's why it's bigger. And if the next area is area 2 is lesser than area 1, so its height must be lesser than that. So this height, area 2, area 2 and area 1 are not the same. In fact, area 1, you said, is larger than area 2. So that's why this is longer than area 2. So that's why it should go down. Similarly, for area 3, if this is area 3, and this is area 4, there is a difference. They're not the same. Area 4, so as you go up, it really goes down. Okay? Because the height keeps on falling like that. Now, if I'm going to determine what is the moment at the midspan, okay, from 0 to midspan, okay, that's composed of area 1 plus area 2 plus area 3 plus area 4, or the total area. Okay. What is this shape again? Is this a circle? Is this a rhombus? Is this what is this shape?
Trapezoid, sir.
Trapezoid. What is the formula of a trapezoid? Area of the trapezoid. If I'm going to ask you the area of the positive shear, what's the formula of the area of the trapezoid?
1/2 base times height 1 minus height 2. Sakto ba, sir?
Sakto siguro.
Walang
Sa time ganyan, 1/2 base times height.
1/2 base times height 1 minus height 2.
1/2 base.
I-minus first ang height and then multiply by the base tapos i-half din mo siya. Sakto ba, sir?
Sakto ba siguro po? Taas to kayo ito din.
Pero pwede man siya i-divide mo lang, sir, di ba? Ang trapezoid mo ang duha ka buok rectangle tapos triangle.
Yeah,
And
that's
then-
correct. Yeah, that's a way. That's a way. You can do that. But daghan mo gud kayo paagi, no? So that's correct. That's correct. But mas simpler siguro kung imong i-average ang height, like 130 and 50. The height of the other side is 130, right? And the hinidapit is 50. So what is the average of 130 and 50?
90.
Still average of 50, huh?
90, sir. 90.
130 plus 50 is 180 divided by 2, 90. So that's the average height. Multiply din mo siya o 4 na width. So 90 times 4 is,
360.
so this is 360. What is the unit? The unit of the height is kilonewton and the width is meter. So you have kilonewton
Meter.
meter. Kilonewton meter. Okay? So kilonewton dot meter, not minus kilonewton dot meter. Meaning dot sometimes represent multiplication, dot multiplication. So kilonewton, which is the one that multiplied by the meter here. So kilonewton meter. So the moment at this point is 360 kilonewton meter. That is equals to area 1, area 2, area 3, area 4. Okay. If you want to determine the moment at 2 meters here, at 2 meter, because what we determine is at 4 meter, and this is 0 meter. So what do you think is the moment here at this point? Is it 1/2 of the 360 or more than 1/2 or less than 1/2? If you want to determine the moment here, as you know the moment here 360, is this 1/2 of 360? For sure, this is not 360, less than 360. And this is also more than 0 because 0 is here. So what could be here? It is more than half of the 260 or less than half of the 260?
More than half, sir.
Okay. What is the magnitude? Using the average height, what is the height of the shear diagram at 2 meters?
$90, sir.
Okay, 90. And the other side? What is the value of the shear at the start?
130.
130. So the average of 130 and 90 is
110.
110. Then what is the distance from here to here?
2 meters.
2 meters, sir.
So what is 110 times 2?
4.
110 times 2?
220, sir.
So this is 220 kilonewton meter. Okay, like that. Okay. So you can also determine the moment here, no? But you use this height and this height. If you want to determine the moment here, you use this height and this height multiplied by 3. Then you can determine the moment here. If you want only to determine this area, 90 plus 70, then you add up that by 220. Then you will have the moment here. But if you start from here to there, you can get this. Okay. So on the other side, you assume to have a curved line because of the shape, trapezoid. But this line goes down. Okay, it's like that. Let us say I want to determine the moment here, here at 5 meters. What will I write here? I know that this is 0. And I know at 6 meter, by principle of symmetry, this is still 220. How will prove this? We will prove this. Okay. Kung imo ni siyang piluon pa ingon didto sa pikas, in such a way that A will meet B, makita nimo ang iyang mirror image. A mirror image. So, if this is 220, this is still 220, but we can still prove that, no? We want to determine this area here, this one. What is this area? By the use of the average side. So, that is 50 and 70. 50 plus 70, how much? Anybody? 50 plus 70. What is the area here? No, ang area na lang.
60, sir.
60. So,
60,
60 minus 60 because this is
300, sir.
300.
300.
Kini siya, pila may area niya? 70 and 90 divided by 2 times 1, kaya 1 naman eh. So, pila yung hitabo niya? What is 70 plus 90 divided by 2?
80, sir. 80.
80, sir.
80. So, 300 minus 80.
220.
220. So, exactly. So, kung mo na siya i-determine, kung maka-determine ka na ni, nagyapon to siya, no?
Ah, so 190.
So, ini siya, pila mo ni? 90 plus 110, pila mo ni?
200.
Divided by 2.
100.
100, sir.
Times 1.
100.
So, that means kini siya 120.
20. Ah.
Dugay na sa inyong statics. Okay?
Ah.
So, then, napagi ka din eh. What is 130 and 110? Divided by 2. 120 times 1. So, it will go back to 0. So, this one is calculated wrong. Okay, so this is the moment. You can determine the moment here, the moment here, the moment here, the moment here, the moment here. The moment is not a moment is used in the design. No? Like for example, you are going to design this beam, but it's not part of our study just to appreciate why we need to analyze. This one has bigger moment, so middle needs not over enforcement here. So if you are going to make a reinforced concrete beam, so let us say this is the reinforced concrete beam, you put bars, so many bars somewhere here in the middle. Put many bars here. Why? Because you have maximum moment. Okay, and maximum shear also meaning there's a lot of shear reinforcement here. That's why you see a lot of tie wraps. Tie wraps. If you are already in your OGT, you will encounter these main bars and tie wraps in the reinforced concrete beam. Doon na siya yung mga bars. So, you need the reinforcement on where the critical force is. The critical is here maximum. So, in fact, if you load it to failure will start at the maximum moment and at the maximum shear. So that's why you see a lot of cracks here. Cracks here if the beam is not reinforced well, it's not one. So you see a crack here. Because why you have crack there? You have maximum shear. And also you have textural cracks here. Why you have crack there? Because you have maximum moment. So in order to use that crack is you put the reinforcement here, not the reinforcement here. Reinforcement. So that in actual situation, the crack will not happen. Why it will happen? Why it will not happen? Because it is well reinforced. Why cracks appear? Because it's not well reinforced. It is overstressed. Okay. In order that the structure will not or will have minimal crack, is you have to well reinforce it. And how do you know where the location of the reinforcement? Through analysis. Okay. That's the purpose of analysis. Okay. So, to summarize what we have done so far, I have introduced to you the types of support as it appear in the actual and how we idealize them. So in the beginning, in the early part of our discussion, I show you the actual pin support, actual roller, actual fix support. Actual fix support is actually like this. This is fix. That's fix. So in reality, fix is like this. This is also fix. This is how beam and column are connected. Okay, in actual, this is the fix. Okay. Again, this is fix. So this one is a cantilever beam. A cantilever beam is also fixed on the other side. It's not pin connected somewhere here. If this is pin, this point should be in the ground. Okay. So now we need to idealize so that we can analyze. Okay. We can complete our load diagram, and from the load diagram, we can apply equilibrium. And then once the load diagram is already in equilibrium, then we can start determine the internal forces, which are the shear and moment. In fact, in my example here, you can determine the shear at any point. No? You can determine moment at any point. No? At any point. So it's like that. So that's the purpose of identifying support properly. No? How to identify roller support, how to identify pin support, how to identify fixed support, in order that we can idealize the structure as CR in actual into a model. Because as I have mentioned, you cannot directly analyze actual structure. You need to idealize actual structure and reflect them into your model or in paper if you are doing some long hand calculation, and then from there you can apply the theory that is behind the analysis of structure. Okay, so to continue, this is the fixed support. Okay. So, okay, that's fixed support. Break sa takajut. 10 minutes lang. Kaya magkapis ako.